Hey, hello guys, welcome to Network Beats. This is Tangadurai. And in our last video, we have played on router 4 by manipulating the weight attribute just to see how we have controlled the route advertisement and to choose one path over the another path, right? So what if that is fine when we have one router on a single AS as exit point, right? If you see AS 400, we have R4 is the only one router acting as a edge router in that particular autonomous system. So what if I have more than one router in the exit path or as exit router or a WAN edge router, right? So in that case, weight attribute will not be helpful to us, right? So for that, we can take example as AS35, right? We have two routers, router 3 and router 5. Router 3 is connecting to AS400 and router 5 is connecting to AS500. So this router 3 and router 5 can receive the prefixes from AS400 either directly from the AS400 or through AS500, right? So this is how AS35 can receive prefixes from AS400. So let's see what we can do. Before continuing, just let me show you uh, in R4. So this is how the BGP table looks like. We have prefixes, right? Whichever the next stop is showing 0.0.0.0 is nothing but the local route, right? Which are associated with AS400 itself. So, whatever the prefix is, apart from the next of 000, is that we are receiving through the different autonomous system number. Like if you see the 5.5.5 and the 55.55.55.55 is we are receiving that through AS 500 and then directly via AS 35 because this 46006 is somewhere here that is connecting, that is receiving via the link from the through the link router 6, okay, and this 3.3.3.3 is to the direct BGP neighborship with R3. So that is how we are receiving these updates. But as per the current scenario, for 5.5.5, the best path is through AS35 itself, and for the 55, the best path is 46.0.0.6, that is through AS500. This we have manipulated by doing some route map configuration. Let's remove that. We don't want to complex it anymore because we are out of that weight attribute for as of now. So let's see, show route map what we have configured. Show route map. Okay, let's remove, before that let's see the configuration of BGP and let's remove these route maps. Okay, so router BGP 400, I'm just going to remove this route map. So what happens now? Let me clear RPBGP chart soft in and out, or just you can say soft. This will clear both inbound and outbound direction updates. It is a BGP soft reset, right? Let's see the BGP table now. Now, the 5 for the 5 network, the best path is via AS35, which is a directly connected AS, and for 5.55 prefix also it is the same, right? But previously it was showing the best path is through AS500, that is not the case now after removing this particular configuration. All right. Okay. So here we are going to play with local preference. Let's see what I'm going to do. Here, R3 and R5 are the two edge routers I have in AS35. Edge router means they have the connectivity to the external autonomous system number from their local autonomous system, right? So here, let me say this is my primary link, okay? That is R3 and R4 is my primary link because I have the direct connectivity between AS35 and AS400. And whenever this link goes down or whenever the connectivity is not available, that means the connectivity between R3 and R4 is down due to any reasons, then I have to prefer the traffic via AS500, whichever is going from AS35 to AS400. So if it is a scenario, if it is a case study, then how we can do the configuration? Excuse me. Okay. So in R3, our objective, our traffic should use this link, right? For communicating with AS400 as a primary. Whenever this is not available, then it should use the path via AS500. So what do we use? Can we use wait attribute here? Yes, you can use. There is no harm in doing that. You can configure a wait attribute on R3 and setting up the wait highest wait on this link on the gig 2/0 comparatively gig 1/0, right? So the highest wait will be first preferred. So this link will be your exit point. But what about R5? Okay, it doesn't impact any the configuration whatever you do on R3 does not impact anything on R5's behavior. Let's say for time being R5 uses the best path via AS500, then this configuration will not do any changes on an R5. So I think I'm confusing you guys. Let me just go and see what is there currently in R5. So R5 is receiving 4 prefixes currently via router 3, which is through this link, right? So let me just so the best path from R5 is like this. Clear BGP is char. Let me just clear and sorry, I have cleared the sessions and just to ensure whatever we are seeing is correct and there is no false information because I was doing some lab and practicing before recording this video. Uh, okay, so the best path for 4 network is via the 3, that is its local AS. It is not preferring AS500. Sure, and section BGP. Let's see if anything is configured. Okay, so we have not done anything major here. Okay. Okay. So what we can do here is let me just go and configure okay, since it is R5 is already using the best path as via R3, there is no sense, right, making it if I do this configuration, even though it is going to use the same path because R5 already it is using the path via R3 to reach AS400 as a primary path, not through AS500. So in this case, let me slightly change my case study so that we can just observe that R5 uh, behavior is not getting changed. So in this case, let me just change my view that AS500 is my primary path, not the direct link. Okay, so I'm going to just do the weight configuration on R5 and I'm going to see whether it is going to impact anything on R3's configuration. So let's go to R5 and how to do the configuration, weight configuration. Let me just create a route map and let me give it a name weight 200 and let's say permit and the sequence number is 10. set weight set weight 200, oops, 200 exit, and let me create some dummy route map for sequence 20 entry. Okay, because we haven't matched anything, so by default it has to match everything, so this is not required, but still by practice I'm just doing it. So the next part, we have defined the route map. So let's go into our BGP, which is router BGP 35, and the neighbor is 25.002, and I'm just going to uh, call my route map here. Route map, the name, okay, and now the question is like whether I'm going to apply it in inbound or outbound, right? So it is a biggest thing which will confuse us in most of the cases. So if you see here, let me just explain that. So here this BGP router 5, okay, will set the weight as 200 whenever it is started receiving the prefixes from through R2, right? So whatever is coming from R2, that is inbound update for R5, okay. So for that particular update, R5 is going to put the weight as 200, right? So this is as simple as that. There is no big challenges to configure this. Okay, so it is just an inbound. So whatever that means, just let me repeat it. So whatever this R2 is updating to R5, R5 is going to receive that and it is just going to put the weight as 200. So whatever the update is coming for R5 is an inbound update, right? So that is why we are giving it as inbound. If you say outbound, then this route map will not be applied for your updates for this particular case. So let me just show IPBGP. So I cannot see any 200. Let me clear IPBGP star and let me give show IPBGP. Okay, previously I didn't see here any weight setting 200, but now I'm seeing the 200 is applied on my BGP table, because for time being R2 is only sending the prefixes which are coming from router 4, which is 4.4.4.4 and 44.44.44. For those two prefixes, now R5 set this into 200. So let's try to ping this whether we have a connectivity to that source loopback 0, because whenever you initiate a ping on this topology on this network, I haven't advertised these WAN IP address subnet or WAN subnets, right? Only I have advertised my loopback IP address to peer for peering and for network advertisement. So R4 is only know about R5's loopback IP addresses, but not 25 subnet. So that is the reason. If you just ping without source command, then this will not be successful for you. So when you initiate with source loopback 0, yes, R4 know about R5 loopback 0 IP address, which is 5.5.5.5. right? The source IP address, and that is why our connection is successful. But when you are pinging 4.4.4.4, your source is not 5.5.5. Instead, your source is 25.0.0.5 will be your source IP address, which is show IP interface brief pipeline include up. So this is what your source IP address when you are initiating a ping 4.4.4.4. So I hope this is clear. And okay, we have done the configuration in R5, and we have seen the changes, and let's go to R3 and see how do our router 3 looks into it. Show IP BGP, how he is going to communicate with R4, sorry, 4.4.4. So here, let me just clear the BGP session. Okay. Okay, so here, okay, still we haven't, still the best parts are not populated yet. Let's wait. Here your, let's give a minute, it takes time. Show IP BGP summary, right? Okay. We are loading 4 prefixes through R5 and 2 prefixes through R4. Okay, here we go. So the weight all are 0, right? And for 4.4.4. network, the best path is via R4, okay? But in R5, we have done the weight attribute changes so that the R5 best path is via AS500, right? But the problem here with R3 is he doesn't care when you do a weight configuration, weight attribute configuration on R5, because we know weight attribute is local to the router, right? So whatever you do on R5, R3 is not going to uh, obey to that configuration. That means like still R3 is going to communicate. It is going to use this link, right, which is directly connected to AS400. So what we can do here, so we cannot use weight attribute. So here we have to use local preference. So how to do that? Sure, and section BGP. Okay, sorry for that, guys. Here, let me remove this configuration and let's play with local pref. So neighbor route map, everything is same, but I think we haven't defined any route map for this. So let's create a route map. Route map. Let us give give it as a name called local pref, and the default value is 100. Look for local preference, right? You can see that here. So we have to use something higher than this. So that means even you can use 101 or 200, whatever you want, but it should be greater than 100, right? So let me use 110, okay, just as a round number. So here let me, okay, that's it. Here I have to give a permit and sequence number is 10. Set local preference and the value is 110. That's it. Let me create one more dummy route map. That's it. Okay, so now we can call this route map under BGP. So router BGP 35, and for which neighbor we are going to do that? We are going to do that for through AS500, so which is having a peering with router 2, if I'm not wrong, right? It is router 2. So the route map name the which we have created now for local preference, and still it is same. Again, we are going to call, like we have to define this as an inbound, right? Because I have told you already, like whatever the updates is coming through R2, for these updates are inbound updates to R5, right? So whichever the prefixes are incoming to R5, R5 is going to do the BGP algorithm, and it is going to assign our path attributes to that. So likewise, it is going to update the local preference value whichever it is received through R2. So that is what we are going to do with. So it is an inbound. If you, what if you do outbound, right? So it is quite abnormal to our case study. When I say outbound, so whatever I'm advertising to R2, right, for those prefixes, I'm just asking R5 to set the local preference value 110. So this is meaningless to me, right? Why I want to set local preference 110 for my outgoing updates? No, because I am getting some prefixes where actually which is my destination prefixes. By knowing that only I can go and reach my destination prefixes. Okay. Once I receive the destination prefixes on both the ways, I have to decide through which I have to go. So I have received the prefixes from R4 and also from R2, okay, in two ways. But I want to prefer R2 path, okay. That how I can do that? By setting the local preference, okay, and I have to apply this local preference for the inbound direction. That means for the prefixes which we are receiving towards the AS35, right? Okay. I think it is confusing, but once you start practicing this lab, it will be clear for you guys. So let's go and see the BGP. How does it look like? So the local weight is still 200. We have already removed it. BGP is bit slow, so you have to wait, or simply what you can do, you cannot wait for the whole day, right? So do clear IP BGP star. So this will hard reset, but you don't do that. After star, you have to just give the command called soft. Okay, that means without killing your neighborship, you are just asking your neighbor to send the updated BGP table what they have, so that you get the new details, right? Now we have done the configuration, so we are requesting for the BGP to get the new BGP table from its neighbors. That means from router 3 and router 2. So let's go and see the BGP table. How does it look like now? So we can see the local perf of 110 for 4 network and 44 network. That's great. I have done the configuration on R5, but what is the view of R3? How it is behaving now? Whether he is still going directly to R4, or now whether he is going through R5, R2, and then it is going to reach R4. Let's go and verify that on R3. So clear IP BGP star soft and show IP BGP. See here, now the best path is not via R4, right? And the best path is not via R4, it is via R5. That is really a great, right? Uh, this is how the local preference play in this particular scenario. This is how you should know, like which attribute that you should configure when you have in your network, when you are using a BGP to get out of your network, or how to manipulate the paths. So we can verify this. Just first, let's ping the destination prefix, just to know whether we have the connectivity. Yes, it is pinging. Also, let's do the trace route so that we come to know which path it takes. Uh, Still it is taking R4. I'm pinging R3, R4, right? It's supposed to go via R5, but the trace would say it is not seeing R5s. Let me just do trace route for 44. Okay, this goes via R5. That's great. Let's go and see what's there with R3. Assurance section BGP. It was good that we have used the traceroute command. Otherwise, we didn't know that R3 was still using the direct link to R4 instead of using the link through R5. But still, my BGP table says that the best path is via R5. But I don't know why it is still using the next stop as the directly connected link. Let's find out what was the issue. So here I have, okay, all good. So I don't have much configuration over here. Let's go to R4, assurance section BGP. Okay, do we have anything here? No, there is not much. So just we have the neighbor commands, and in R3 we have neighbor commands. Okay, and okay, and R3 to R5, all good. Show IP BGP. Trace route 4.4.4.4. It is still using. Interesting. Sure, and okay, so there is a static route. I was suspecting that, okay, because there is a rip failure over here. Okay, so this is the reason why we are not receiving this. Okay, so that's fine, because this static route we have, if you see, sure and section, sorry, already we have that. We are connecting, we are having the BGP neighborship using our loopback IP address, right? So if R3 want to pair with R4 first using their loopback IP address first, R3 should know how to reach R4 loopback IP address. Because of that reason, this 4.4.4.4 was statically defined so that R3 know how to reach 4.4.4. If this entry is not there, then R3 cannot have the BGP relationship with R4. You should see the BGP peering going down for R4 now. Show IP BGP summary, clear IP BGP star soft. Now the rip failure was gone, and I think it is waiting for that whole timer. Play IP BGP. Let's do hard reset and check whether our BGP is coming up or not. See, the neighborship with R5 has come up, but with R4, it is still down. It will never come up. Why? Because RT doesn't know how to reach R4. Okay, because of that reason, we have defined that static route. That's fine. We can simply we can put it up, no problem. But for us, we have the another prefix from 44, right? So that is going via AS500. So that is good for us. So we are good as per our case study. Now we should see the peering should come up. Show IP BGP summary. Clear IP BGP star. Okay, the neighborship has come up. Fine. If we want to fix this up in another way, yes, we can do that by directly peering. Instead of peering over the loopback IP address, we can directly peer using their the subnets which we have configured on the physical interface, right? That we can do it, but we don't have much time for this lab for this scenario. So let's end our session here. Before end up, let me just re-verify and show you that what is happening here. So R4 is sending its prefixes, right? R4 is advertising 4 network and 44 network, and in two different ways. And we have configured a local preference on R5, and we haven't done any configuration on R3. We have not done any configuration on R3. Just by doing the local preference configuration on R5, that information was also populated to its internal AS neighbor, IBGP neighbor to R3, so that R3 is also using the AS500 as a primary path for reaching the prefixes whichever is coming from AS400. Okay, for time being we don't have the prefixes coming in from any other AS, only we have the AS400. So that's it. So thanks for watching. I hope this video was helpful to you guys. We'll see you in another video. Thank you.